You know, I look up at the night sky, really dark out here, beautiful, and I see stars. A few bright ones, some faint ones, lots of little pinpricks, but mostly black, huge amounts of black. Now that's funny, because if you think about it for just a minute, really think, you realize the universe is full of stars, not just a lot. Billions in our galaxy alone, and billions of galaxies beyond that, going on and on. If they were sprinkled around everywhere forever, like sand on an infinite beach, then everywhere you looked, every tiny little direction your eye could point, your line of sight would eventually hit a star. Some close, some far away, but something. The light from all those stars should pile up, layer after layer, until the whole sky is as bright as the surface of the sun. You shouldn't even have night. You should be sitting here in broad daylight at midnight. But we're not. The sky is dark. So what's going on? Why isn't the whole heaven lit up like a furnace? Furnace, it's such a simple question, almost childish. And yet it drove smart people crazy. For centuries, they called it a paradox. I call it one of the most beautiful clues nature ever left lying around. Tonight I want to talk about that clue, what it tells us about the size of the universe, the age of things, the way time and light and space are playing together. Because the darkness up there isn't just empty. It's telling us something deep, something surprising, something that changes the whole picture of how big and how old everything really is. You look up at the night sky on a really clear night, way out, where there's no city lights messing things up. And what do you see? A few bright stars, some medium ones, a whole bunch of faint little pinpricks, and between them, mostly nothing. Black, vast stretches of black. It's dark up there, really dark. Now that seems perfectly ordinary nighttime, right? But stop and think about it for a second. Really think. Suppose the universe goes on forever, not just big, infinite. And suppose it's stuffed full of stars everywhere, going on and on without end. Not clumped up in funny ways, but spread out nice and even like sugar, sprinkled uniformly through an endless cup of coffee. And suppose those stars have been shining forever, no beginning, no switching off. If that's the case, then pick any direction at all, any tiny angle you point your eye, and keep going straight out. And your line of sight has to hit something eventually. Because the universe is infinite, there are stars at every distance, some close, some farther, some ridiculously far. So no matter which way you look, that line bumps into the surface of a star sooner or later. The light from that star comes streaming toward you. And since there are stars, behind stars, behind stars, all the way out, every single direction should end up with light piling on from nearer ones and farther ones. Now here's the clever bit. You might say, okay, but distant stars look faint, light spreads out, gets weaker with distance. True enough, brightness drops off as the inverse square of the distance, twice as far, 4 times dimmer. But watch what happens when you add them all up properly. Imagine thin spherical shells around the Earth like layers of an onion. The nearest shell has some star in it. They're bright because they're close. The next shell out is bigger in area. Its surface is 4 times larger if the radius doubles. So it has 4 times as many stars, since they're spread evenly. But each of those stars is 4 times farther away. So each one is 4 times fainter. 4 times more stars, each 4 times dimmer. Cancels out. The total light coming from that shell is the same as from the first shell. Do the same for the shell twice as far again. Area goes up by another factor of 4, so 16 times more stars than the first shell, but each is 16 times fainter. Again, same total light from the whole shell. Every shell, no matter how far out, contributes exactly the same amount of light to your eye. And since the universe is infinite, there are infinitely many shells. Add up infinite contributions, each the same size, you get infinite brightness. The whole sky should be glowing, bright as the surface of the sun itself. Not just a little bright, blindingly bright. You shouldn't have night at all. You should be sitting here in the middle of the day, every direction pouring sunlight level glare on you, no shadows, no dark patches between the stars. The entire heaven ought to be one continuous furnace of light, but it isn't. We look up and see mostly black. That's the puzzle. That's simple everyday fact. The darkness between the stars contradicts this picture of an infinite, eternal star-filled universe in the most dramatic way. Something has to give. One of those quiet assumptions we started with must be wrong. And nature is telling us which one, if we just listen carefully to that. Darkness. But it isn't. We look up and see mostly black, huge patches of nothing between the little points of light. Not bright at all, not even close. The sky is dark, really dark, and that darkness is screaming at us that the simple picture we just painted can't be right. So what's wrong? We built this argument on three big, quiet assumptions. First, the universe is infinite in size. Space goes on forever. Second, it's eternal. No beginning. Stars have been shining forever. Third, it's full of stars, roughly the same way everywhere. No big empty gaps that go on forever. If all three are true, then the sky has to be bright. Since it's not, at least, one of those has to be false. People have been chewing on this puzzle for a long time. It's called Olbers Paradox, after Heinrich Olbers, who wrote about it in 1823, though others noticed it even earlier. They tried all sorts of fixes. Maybe space isn't transparent. Maybe dust or gas absorbs the light from far away. That sounds reasonable at first. But if there's enough dust to block distant light, it would heat up from all the starlight hitting it. Pretty soon, that dust would glow red hot or white hot, and you'd see it shining instead. The sky would still be bright, just with a different color. Dust doesn't solve it. It just moves the problem. Maybe stars aren't everywhere. Maybe the universe has big holes, or the stars stim out so much at great distances that the shells don't keep contributing the same amount. But if you make the density drop-off, you're basically saying the universe isn't uniform forever. And if it's infinite but mostly empty far out, why should it look that way? It feels like patching things up without really explaining. Maybe the stars have finite lifetimes. They don't shine forever. But if the universe itself is eternal, then even if each star burns out after a few billion years, new ones should keep forming. Everywhere, all the time. The average number shining at any moment should still be the same everywhere, and the light from all dead stars would still be arriving from far away. You'd still get the pileup. The real trouble is deeper. When you add up those infinite shells, each giving the same light, you get infinity. But infinity is not a number you can just sit with. The brightness would be infinite, which means blinding, which means the whole idea breaks down. Nature doesn't do infinite brightness in a finite place like your eye. Something fundamental is off. The darkness isn't just a small detail, it's enormous. Most of the sky is black, 99.999% or more. The stars we see are tiny exceptions. That means whatever is wrong with the assumptions, it's wrong in a way that makes almost all directions empty of incoming starlight. Not dim, not blocked, just not bare. No light has arrived from those directions. Think about what that implies. If the universe were truly infinite and old enough, every line of sight would have had infinite time to fill with light from infinite stars. The fact that it hasn't means time isn't infinite backward, or space isn't infinite in the way we thought, or both. The dark sky is like a shadow cast by something huge, something that limits how far light has traveled to us. It's as if the universe has a horizon for light, not because space curves or anything fancy like that, but because there was a time when things started. Light only has a finite time to get here. Distant places haven't had their chance to send their light yet. The blackness is the absence of news from beyond a certain distance, news that's still on the way, or maybe never coming, because the sender wasn't shining back then. That darkness between the stars isn't empty space doing nothing. It's evidence. It's the universe saying quietly but very clearly, I haven't been he, forever. The real answer, the one that makes the darkness make sense, comes down to this. The universe hasn't been around forever. It had a beginning. Imagine the stars aren't eternal. Imagine there was a moment way back when everything started. Not just some stars turning on, but the whole show kicking off. Before that moment, no stars, no light, nothing shining anywhere. Call it the Big Bang if you like, though the name is a bit misleading. It wasn't an explosion in space. It was the beginning of space itself, time itself, everything expanding from an incredibly hot, dense state. Now light doesn't travel infinitely fast. It goes at a fixed speed, about 300,000 kilometers per second, fast, but not instant. So even if the universe is huge, maybe even infinite in size now, light from faraway places has only had a finite amount of time to reach us. Since the beginning, about 14 billion years ago, that light has been traveling toward us at that one fixed speed. Picture it like this. Suppose the universe is infinite in extent right now, full of galaxies everywhere. But rewind the clock to the start. At time zero, everything is crammed together, no distances yet. Then expansion begins. Galaxies, or the stuff that becomes galaxies, fly apart. Light starts streaming out from stars as they form. From our spot today, the light we see from a nearby star took, say, 4 years to get here, if it's 4 light years away. From a galaxy 1 billion light years away, the light we see left there 1 billion years ago. We're seeing that galaxy as it was 1 billion years in the past. Now go farther, much farther. There's a distance where the light would have needed more than 14 billion years to reach us. Beyond that distance, no light from stars or galaxies has had time to arrive yet. Those places are out there, maybe. Stars are shining there right now, but their light is still racing toward us. It hasn't gotten here. It won't get here for billions or trillions more years, depending how far. So when you point your telescope in a random direction and see nothing but black, what you're really seeing is the edge of the observable universe, not an edge in space, but an edge in time. It's the farthest back in time that light could have traveled since things began. Beyond that horizon, no signal has reached us, no starlight, no galaxies, just silence, darkness. That's why the sky isn't bright. The infinite number of shells we talked about earlier, only the shells within our light travel time horizon contribute light. The ones farther out haven't sent their contribution yet. There aren't empty shells worth of light piling up. Only a finite number, because time is finite backward. The total brightness is finite, and mostly it's low because stars and galaxies aren't packed densely enough even within that horizon to fill every line of sight. Moreover, as things expand, the light from very distant sources gets stretched, redshifted by the expansion itself. The wavelengths get longer, energy per photon drops, so even the light that does arrive from far away is dimmer than it would be in a static universe. But the main killer is simply that most of the potential light hasn't arrived yet. The blackness is therefore not a flaw or an accident. It's the direct consequence of a universe with a finite age. Every dark patch between the stars is a little window into that beginning, a reminder that the cosmic clock started ticking a long time ago, but not infinitely long ago. Without a beginning, without that cutoff in time, the sky would have to be blazing. Because it isn't. The universe must be young. And young it is. Only about 13.8 billion years, give or take. That number isn't pulled out of thin air. It comes from measuring how fast things are expanding now, tracing backwards, seeing when everything would have been squeezed together. The dark night sky is one of the oldest pieces of evidence we have for that finite age, for the fact that the universe isn't eternal and static, but dynamic, born, evolving. So the next time you look up and see all that black, don't think of it as empty. Think of it as history. It's the universe's way of showing its birth certificate. So there you have it. The night sky isn't dark by accident. It's dark because the universe is telling us its own story. It had a beginning, it's young, light is still on its way from the farthest places, and the blackness between the stars is the biggest between the stars is the biggest. Quietest proof we have that everything did need just always exist. Next time you step outside on a clear night, look up at all that black. Don't feel small or lost. Feel curious. That darkness isn't emptiness. It's history. It's the universe whispering. I'm only 14 billion years old, and there's so much more still coming. Thanks for coming along on this little thought adventure with me. I hope it made you wonder a bit the way nature always makes me wonder. If this sparks something for you, if you're thinking about the stars, the Big Bang, or just why the sky looks the way it does, hit that like button. Drop a comment with your own questions or crazy ideas, and maybe subscribe so we can keep chasing these puzzles together. The universe is full of surprises, and there's always more to figure out. Started not too long ago, and light is still catching up.